All right, friends, let's solve some equations. So as you see, there are 4 main types of equations to solve. We're going to start with the easy ones and then get to the really good ones at the bottom. All right, so first type of equation are just linear equations. So linear means that you have a variable, but it's just to the first power, no fractions, no funny business. Here, what we want to do is focus on one side at a time, simplifying each side, getting all the variables to one side, and then finally solving, right? So if we look at the left-hand side first, we're going to distribute that -5. So -2 minus 15 plus 5x. If we combine these two, -2 minus 15 is -17 plus 5x. So notice I'm just working one side at a time. When I look to the right-hand side, I'm going to distribute that 6, get 12x minus 6 minus 2. Since I'm still on the same side of the equal sign, again, I'm going to combine -6 minus 2 is -8. So we get 12x minus 8. All right, so we simplified both sides. Now what we want to do is get all the variables on one side, all the numbers on the other. It doesn't matter which side you move them to. I like to move the x's over to the larger side. So since 12 is larger, I'm going to subtract the 5x here. So I get 7x. And so if I'm going to make this the side with all the variables, then this -8 can't be here. So I'm going to move that guy over here by adding 8, so -17 plus 8 is going to give me -9, so I get 7x equals -9. To solve, I'll divide both sides by 7, so x equals -9 sevenths, and we are good to go. Fractions don't necessarily mean you did something wrong. It's okay, you can handle fractions. All right, so linear equations, good little warm-up. Let's move on. So here we have equations with fractions in them. This says fractional. You might also see them be called rational equations. Rational means fractions, right? So what we want to do is when we're dealing with rational equations or fractional equations, what we are going to need is an LCM, a least common multiple. Okay, this least common multiple is going to help us clear out the fractions so that we can turn this fractional equation into a linear equation, because as we see, those are just way easier to deal with. So when we have fractions, we're going to multiply every single fraction on both sides, everything, by whatever the least common multiple is of the denominator. So we're going to look at 5, 4, and 40. What is the least common multiple? Meaning, what is the smallest number that 5, 4, and 40 all go into? Well, that LCM, in this case, is 40. So what we're going to do is multiply every single term by 40. Okay, so we're going to kind of distribute that 40 on both sides of the equal sign. Look at what happens when we do that. When we do 40 times 2 divided by 5. 40 divided by 5 is 8. 8 times 2 leaves us with 16, right? When we distribute here, 40 times 3 divided by 4. Now, when you're multiplying and dividing, we can also do 40 divided by 4 is 10. 10 times 3 is 30, and that's a minus sign. So minus 30x. Notice there is an x there. And then when we multiply this guy by 40, 40 times 1 is 40. Divided by 40 gives us 1, right? So however you want to think about that, I put on the outside. If you don't like that, if that's confusing to you, you can also think of it, put that times 40 here, times 40 on each of the little fractions, and then you can reduce while you're working. Like 40 divided by 5 is 8, 2 times 8 is 16. 40 divided by 4 is 10, 3 times 10 is that 30x. And then we have 40 divided by 40 is 1, 1 times 1 is 1, right? So you can multiply, show your work, whatever makes sense to you. But either way, when you multiply by the least common multiple, look at how we go from this messy equation with all these fractions to this way easier linear equation to solve. From here, I'm going to subtract 16 from both sides, right? Bring this guy here, minus 16. So we're going to get negative 30x equals negative 15. Divide both sides by negative 30, and our answer is 1/2. Okay, awesome. All right, next one we have over here. So again, rational equation. The bubble here is, don't forget to multiply by that least common multiple, but don't forget to multiply both sides of the equation by the least common multiple to clear that fraction. So when we're looking at the denominators here, the denominators are 3 and 2. The LCM, the least common multiple of 3 and 2, is 6. So I'm going to multiply every fraction by 6. Okay, when we do that, what we're going to see is that the fractions will reduce a little bit. Like 6 divided by 3 is 2. So what we're left with is 2 times that 4x plus 2. Minus, when we clear the fractions here, 6 divided by 2 is 3. So minus a 3 times that 3x minus 1 equals 6 times 1 is just 6. Right? So now we're again transforming this rational equation with all these messy fractions to a much easier linear equation that we can solve by distributing the 2, so 8x plus 4, distributing that negative 3, so negative 9x plus 3 equals 6. Combining like terms, 8x minus 9x is negative x. 4 plus 3 is positive 7 equals 6. Now we can start moving, so I'll move that 7 over, so I have negative x equals negative 1, so x equals positive 1. Nice. Remember, guys, if at any point you need to pause or rewind, this is a video for you to use in whatever way is most helpful, so please feel free to do that. All right, next skill is solve by factoring. Remember yesterday? You guys remember all these factoring skills we reviewed yesterday? It's not, these skills don't just help with factoring, but there's a bigger picture, and that's solving quadratics, right? It's solving equations. And what's going to determine whether or not you solve for x? So when the directions say solve, your answer is going to be x equals usually 2 numbers. What you have to do in order to do that is you have to set the original equation equal to 0. Okay, make sure you set the original equation equal to 0. And make sure you read the directions, right? It's going to say solve. And when the directions say to solve, not factor, that's when you set the equation equal to 0. All right, so here we see the quadratic, we see the equal sign, so we know we're solving, but it's not equal to 0. So our preliminary step here is first to set the equation equal to 0. So I have to move that 12 over by subtracting it. So I'm going to have y squared plus y minus 42, and now it equals 0. So now I can solve by factoring. I'm going to use the same steps that that we practiced yesterday to factor this. So because this is a trinomial with a leading coefficient of 1, it's more of that simple factoring. What 2 numbers multiply to negative 42, add to positive 1, that's y plus 7, y minus 6. So we factored it, right? This step to this step is the factoring, but we need to solve because that equal sign. So now what we're going to do is set each of these factors into their own mini equations, being set equal to 0. And then when we solve, we get y equals negative 7 and positive 6. So notice our final answer are those 2 values for what would make this original equation true, right? And one of the great things about solving equations, you can always check your answers, right? We can always take the negative 7, plug it into here and here, and the left-hand side should equal 12, right? Same thing up here. We should be able to take the 1/2, plug it in for x, and get that the left-hand side equals the right-hand side. Same thing up here. So you can always check your answers. All right, so let's take a look at number 2. Solve by factoring. So again, we need this equation set equal to 0. It doesn't equal 0 right now, so we have to move the 2x over by subtracting 2x. We have to move the negative 3 over by adding 3. So when we do that, we're going to get 4x squared minus 21x minus 18, and that's going to equal the 0. Right? So first set it equal to 0. Now we have to factor. Well, I see that my leading coefficient is greater than 1, so I have to use the multiple steps, right? So what two numbers multiply to 4 times negative 18, which is negative, multiply to negative 72, and add to negative 21. Those two numbers are negative 24 and 3. Remember, you can use your calculator to get this. Take your time as you're figuring that out. So negative 24x and 3x. I'm going to drop the first guys down and the last guy down. And I'm going to continue my factoring. This still equals 0, right? After we split the middle term, we factor by grouping. This is all what we practiced yesterday. Take out a GCF of, in this case, 4x. We're left with x minus 6. Over here, take out a GCF of positive 3. Left with x minus 6. There's my common group, that x minus 6. The GCFs come out in front, 4x plus 3. So we were able to successfully factor it. But remember, we need to solve. This equals 0. So now I'm going to set each of these guys equal to 0 separately. So here I have 4x plus 3 equals 0. X minus 6 equals 0. So I'm going to get, if I subtract the 3, I get negative 3/4, and here I get positive 6. So we get our two solutions to this quadratic equation. Again, please feel free to pause or rewind if it's going a little too quickly. All right, so we solved these 3 types of equations. On to the last one with proportions. So proportions are going to look similar. They have fractions in them, right? The difference with this one, this is like a special case rational function, is that there's only one fraction on each side, right? These guys that we saw up here are not proportions because there's 2 fractions on one side and another fraction on the other. So these are rational equations. We're going to use the LCM as that strategy. Here, when there's just one fraction equaling one fraction, the strategy we're going to use here is to cross multiply. Okay, and again, this is a special type of rational, so we can't always cross multiply with every type. So when you cross multiply, you're going to do exactly what it says. You're going to multiply across the fraction. So we're going to take these guys, m times m minus 1, making sure that you write them out with the parentheses. I can't stress that enough. Times, over here we have the 12 times m minus 3. By cross multiplying in this way, do you guys see we now have more of a linear-esque type of equation? So now we just fall back on skills we've already practiced. I'm going to distribute that m, get m squared minus m. Distribute that 12m minus 36. So there's no more fractions, which is good, but I see that squared here, which means I have a quadratic. So just like we did up above, we're going to use our factoring skills to solve. So we can bring these guys over so that to keep the squared term positive, I'm going to keep m squared on this side because we want to keep them positive. So when we move, I'm going to subtract 12m and I'm going to add 36. So we'll end up with m squared minus 13m plus 36 equaling 0, always making sure our quadratic equals 0. Because we have 3 terms and the leading coefficient is 1, this one's going to be the more basic factoring. What 2 numbers multiply to 36 and add to negative 13? That's going to be negative 9 and negative 4. So we were able to set up the quadratic so that the equation equaled 0. We were able to factor, and now we have to solve, where we take each of these factors, set it equal to 0, and we get m equals positive 9 and positive 4. Awesome, guys. So remember, these should all be review. You've already learned these skills in previous algebra classes. But if you feel super fuzzy about this, if you are filling out this chart and even after watching the video, you're right, we're here in this solving. If you're all ones still, please come in. Notice it says after you watch the video, if you vaguely recall this topic and after doing the delta math, you definitely need more practice. Please make sure you are telling me this. I don't want this week to end and you still feel iffy about any of these topics. So make sure you email me, pop in the math office, or talk to me in class so that we can get this stuff figured out. I want you to feel super confident with each of these. It's going to take some work, and that's okay. We can do it together. All right, we'll see you later.